1/2? You would multiply by 2. What if it comes out 1 1/2? You'll multiply by what? 2. If it's 2 1/2, you'll multiply by 2. Okay, I think we got that one down pat. Okay, what if it comes out 1 1/3? 3. But what if your calculator is messing with your mind and puts 1.333, a repeating decimal fraction? It'd still be 3, wouldn't it? Because you're going to recognize that as a third. Okay, what if it comes out on your calculator 1.67?
That's 6 repeated.
You still multiply by 3 because 0.67 is 2/3, isn't it? Okay, if it came out to be 1 1/4, you would multiply by 4. So you will be multiplying in that last column probably by 2 or 3 or 4. Okay, I don't think I've seen anything else. Okay, so now, that's really not the answer yet. We got to take that, and we will use these as our subscripts. So it's going to be 2 sodiums, 2 sulfurs, 3 oxygens. That's our compound. Now, at this point, you don't know anything but that's the empirical formula. You do not know if that's the molecular or not. All you know from the table is the empirical.
I was going to say, now I'm confused with the difference between an empirical and the molecular formula.
Okay.
Because that looks like
This is the lowest whole number. If we go back over here,
So we have to match.
I would have to give you another piece of evidence. Let me give you one that I've got the numbers handy. Let's say we went through that table. We had taken a pure compound. We went through the table. Let me take you back to a really easy one. We get this from the table. Now, all you know at that point in time from the table, that's the empirical or simplest formula. Use those terms interchangeable, empirical and simplest. Simplest whole number ratio. Then, separate experiment, I say the formula weight is equal to 34.0 grams per mole. Okay, I want to move us into the molecular formula or the so-called true formula. Okay, so listen to the awful ways we talk. Empirical and simplest go together. True and molecular go together. Okay, now, here's the point, Brittany. This is the formula weight. So I go back up here and I add these two together, and I would only get what? For this, for as it stands? 17. Not big enough. So I say 17 times what gives me 34. X is 2, so then I take that, H2O2. And in this problem, I don't have the numbers at my fingertips. Does anybody have a formula weight on that? Did anybody mess around and do that real quick?
158.2.
Thank you, Russell. 158.2. Okay, separate experiment. I say, hey, we found out that the formula weight is really 158.2. So, we know it's the empirical. Now, is it also the molecular? Yes.
Now, how did you
Because-
get that? It was 158.
Because Russell was clever enough to do that for me. Right now, we know this is the empirical. Russell took this, and I trust his word, 158.2. Okay, now, this would be a separate experiment. Separate experiment, this is the formula weight. Okay, we add that up, and that does equal that. So the molecular is the same as the empirical.
Is it supposed to give us what the molecular?
Not in this particular problem. It's not going to do that till we move down to section 9.
Okay,
So this one doesn't take you that second step.
Okay.
That doesn't take you the second step.
I kind of lost in the column. Do the same. After
When I call files, like, I really have to divide.
Move it from here to here. Okay, is this column okay?
Yeah, I got that.
Okay, it's just a math trick to get whole numbers. Then, when you get to this point right there, okay, I would hope for whole numbers. And sometimes we get them there and we say, great, we're through. But if you get things like 1 1/2, like we did, then we got to add that last column. just multiply it by some little number to force it into being whole numbers. Because best form, see, this is really a true statement. This is a mole ratio. That's a true statement, but people don't like it that way. They want whole numbers for formulas.
Basically, you want to basically want to turn 1.5 into a whole number, so you divide.
Multiply by 2.
That's not the ratio.
Yeah,
Okay.
Nikki?
You know how you're saying if it came out to 1.3, we would multiply by 3?
Yeah.
But when I was doing that, I just have a question. Because it came out to like 3.9, so we round it to 4.
Mhm.
Okay.
Yeah, okay, when it's, and that's a good point she's brought up, when you know to round and when you don't. Okay, if it's like 2.9, you're close enough, call it 3. Don't think, oh, I gotta multiply by some factor. If you're really, really close, like 3.01, you're 3. Okay, but if you're a half or a third or a fourth, multiply by a factor.